based on these distances, can we reconstruct a route map how we can reach from different areas for patient movement instinct? Right? Based on these distances, we can reach to our college from different areas. So based on these distances, or how each area is similar to our patient memorial Narayana and how each area is far away from the patient memorial institute of Narayana. So in this way, you can see that based on distances, how each area is similar or how each area is far away from Narayana. So this is what a multidimensional scaling is. Based on the distances, only we see based on the distances we make a geometry representation. I will give you another example. I have 6 products of biscuits. Let us take A, B, C, D, and whenever you calculate the distance between A to A, that will be 0. So we have a dimensional or a diagonal matrix which will be 0. And these values right here, if the biscuit A from the biscuit C, if I want to calculate the similarity, if how similar, if they are very similar, then I'll scale it as a 1. If A and C are very dissimilar, then I'll scale it as a 10. If it is 1, then it is a similarity, very similar. If it is 10, then it's very dissimilar. And I am taking the biscuit C and biscuit B is very dissimilar. These values are based on different factors like the biscuit features. Let us see how sweet it is and whether it is a chocolate flavor or vanilla flavor or orange flavor and what type of biscuit it is. It is a sugar biscuit or it contains a dry fruits in it or nuts in it, and based on a healthy. Like we make chocos. These values are based on those factors. How they are similar, how A biscuit is similar to C. If they are very similar, I will scale it as a 1. If they are very dissimilar, then I will scale it as a 10. In this way, what I am doing here, whatever the higher dimensional data I have here, I am scaling down it into lower dimensional data. Like let us take a 1D dimension. I am converting it into 1D dimension. And the distance, the similarity, the distance between A and C is 1. So I can place in one-dimensional data, I can place A and C together. Which is something that there is a very similarity between them. So I will place A and C here. And if you see, between A and B, there is very dissimilar, which is 10. So I need to place this A and B very far. So I will place here. And from A to C, I will take, I have, and if we take another values in, let us take D from A to D. It is very similar, let us take 2. So I need to place here D, which is very similar to D. So if E and D are very similar, if we take this D and B, they are very dissimilar. I will scale it as 10. So I need to restrict that D and B are very far from each other. But A and D should be very similar, very close to each other. But if it is not fitting in this data, if I cannot fit this higher dimensional data in this 1D dimension, I will explore in many dimensions like 2D data or 3D data. Here what I am doing, I am scaling down this higher dimensional data into lower dimension, which is nothing but I am decreasing the higher dimensional data into lower dimension based on their similarities and dissimilarities, which is nothing but a distance. This is what I am doing, multidimensional scale. I hope it's clear when to use the technique multidimensional scale. And factor analysis is nothing but It is based on decreasing the features based on hidden factors, like latent factors. But MDS, it is reducing the dimensions into lower dimension based on a similarity and dissimilarity distances. And the main goal of MDS is to identify the inter-object variables which are very similar and reducing the dimension from higher dimension to the lower dimension in a non-linear fashion. This is not the straight-line definition. And reproducing the non-linear fashion higher dimensional data into lower dimension. And in this multi-dimension, we have two types: metric multi-dimensional and non-metric multi-dimensional. Now let us see about the metric.